Hey guys, so I wanted to share with you one of my favorite tools for doing slope fields. Wolfram Alpha is great. There are computer programs that can be written for MATLAB or Python or different programming languages. This one's just really nice because you get to see the slope field and you get to see the Euler's method results at the same time. So this format may change slightly depending on when you're viewing this video, but up here you can see a lot of these things are clickable. And first thing we want to do is we want to set the differential equation. We'll also use the system tab later on. I've never messed with the polar coordinates or anything like that. In here, if you want to use dy dt, you can. That might just make it a little bit easier to work with. So let's say that this is the differential equation that we want. Maybe even 0.2t minus 0.6y. And so once we press enter, we should see the equation appear here, and that reflects the slope field that we have at the bottom. So here we have the slope field, and suppose we have some initial condition for which we want to plot. Now we can click on this phase plane, or excuse me, the slope field, and we can generate the trajectory, the path that that initial condition will take. Of course, I don't know exactly what that initial condition is right there. I can kind of eyeball it on the y-axis. But I'm going to go ahead and clear that out, and under initial points, if you say clear all curves, that will wipe out anything that has been graphed. And in here, you could actually specify your initial condition. So let's say we do want the initial condition, t is 0, y is 1. If checked, phase plane curves only show results for t greater than or equal to 0. That is forward in time from the initial value following the arrows. If unchecked, they are shown for positive and negative t. So if you don't uncheck this, you should only see, and so back here, in order to get out of this, you actually have to click on initial points again. That didn't seem to work, but that's okay. So here's the trajectory, and instead of using, right now you see that this says RK4. Now that is a numerical method similar to Euler's, but to see Euler's method, click on RK4 and then select Euler from the options. And this H, this is actually what we might refer to as delta t. So if I want to see a step size of 1, I can choose 1 and press enter. And now you probably noticed what changed. You can see that now we have these straight line segments because at any given point, y equals 1, for instance, t equals 1, whatever this particular y value is, it looks like we get a slope of roughly about 0. So there's no change from time 1 to time 2. Now, if we want, the cool thing about this is we can actually look at a table. So if you click on table, if you click on table, then this will actually show you the trajectory. And actually, by checking and unchecking this, this will just show you the dy dt column. And you can actually see in the image how those estimates are taking place. I'm not sure that, yeah, so that just, the bottom of that triangle kind of just shows you the dy dt at that instant. It also goes back. These are the back step segments. Let's see if we uncheck that and submit. Let's try this again. Yeah, this button doesn't seem to work as of the recording of this video, so that's okay. But key point here is that you can see the different t's and you can see the values of y. So if I change this to a smaller step size of say 0.1, press enter, it should for the most part show me everything that is on my graph. You see that how far in time this table goes out is a function of what my window is set to. It's set from about -4 to 4. And if I want to change that, I can actually do so by clicking on the settings here. And let's just say I want to go from 0 to, say, 10. And then maybe for y, I just want to go from, say, this button here. We'll say from 0 to, I like 3. That looks good. There we go. Looks like a really nice graph. And you can see that the table adjusts as well. Now this table will have some limitations in the sense that eventually it may skip some rows because your step size is too small and it just simply doesn't want to display them. Let's see if I do 0.01. Well, it looks like it does continue to show it. Just note that if you see some rows skipped, it just might be because your step size is too small. Let's say I did that. And now you can see that because my step size is so incrementally small, it only shows up to a certain number of iterations. And I think that that magic number is going to be about 1,000 iterations is the max that it can do. So you're going to notice that this can become kind of inefficient for really, really small step sizes, but it's a nice tool nonetheless. We'll talk about constants and expressions, but if you want to play around with that, you can actually add comments. You can copy some plain text values. I don't think you'll need that, but if you're using MATLAB or something like that, that might become helpful. So this is how you use this. This is what I call the Bluffton slope field tool. It's really simple to use. It's really convenient, and you can see slope fields and Euler's tables at the same time.